Up until now, every problem that we've had in Physics 20 has involved either constant or average velocity. And because of that, we've used the equation V is equal to delta D over delta T. That's not going to change. Whenever we see a problem involving constant or average velocity moving forward, we'll still use the same equation, V is equal to delta D over delta T. But now, in addition to those types of problems, we're going to see problems where it's not constant or average velocity, but rather an object is speeding up or slowing down. In other words, we're going to see problems involving acceleration. We define acceleration as the rate of change of velocity. Remember how we defined velocity? The rate of change of position. Anything that's a rate has time on the bottom. So acceleration would be something over time. Velocity was change in position over change in time because it was defined as the rate of change of position. Well, acceleration will therefore be delta V, the change in velocity over change in time. Giving me my base equation for acceleration, A is equal to delta V over delta T. Now, what do you think the units would be for that one? What are the units that I'm going to use for delta V? Up until now, we've been able to use pretty much whatever we want for delta V, for velocity, for instantaneous, for change in velocity. But now, whenever we're dealing with acceleration, it must be meters per second. You must use meters per second now. On all those old problems, you don't have to. You could still use kilometers per hour on a V equals D over T problem. But in this equation, you've got to use meters per second. Time is going to be in seconds, which means acceleration will be in what? Somebody saying it there? Meters per second squared. Yeah. If you look at the units here, we'd say meters per second divided by seconds, right? But we can simplify that. That's the same thing as saying meters per second divided by seconds over 1, which is the same thing as saying meters per second times 1 over seconds multiplied by the reciprocal, which gives me, in the end, that's what's important, meters per second squared. Okay, you write it like this. Is that wrong? No, that's right. But this is a lot tidier, right? Meters per second squared is tidier. So my units for acceleration would be meters per second squared. Now, we're going to open up a whole new ball game today, okay? You've just learned your second equation. You're about to learn your third equation, and your fourth equation, and your fifth equation, and your sixth equation. Because whenever we're involving constant velocity, there is only one. But whenever we're involving acceleration, there's a number of them that are applicable, including the one that we just did, but also including D is equal to VI plus VF over 2 times T. Including VF squared is equal to VI squared plus 2AD. Including D is equal to VIT plus 1/2 AT squared. And including D is equal to, and this one's really close, VFT minus 1/2 AT squared. What do you think delta D stands for in this equation? Change in what? Close. Not change in distance. Change in position or displacement. Delta D stands for displacement. VI would stand for what? Initial velocity. A would stand for acceleration, right? Delta T would stand for time. VF down here would stand for final velocity. VI over here would stand for initial velocity. VF down here would stand for oh, you got it. Who is that, Maddie? Final speed. Good. That might be the first time somebody's answered that question correctly. It is not final velocity. It is final speed. You can see that because the VF doesn't have the little half arrow over it. Most times it's the same value, right? Unless you change directions, it's going to be the same value. But technically, it's not velocity, it's speed. And of course, the VI stands for initial speed, A still stands for acceleration, D still stands for displacement. I want you to look at your data sheet right now. Everybody haul out your data sheet right now. That is, unless it's locked in your running car. Haul it out and take a look at the top of the page. Very top left-hand corner gives us the equation V is equal to delta D over delta T. That's the first one we learned. I want you to circle that right now. Circle V is equal to delta D over delta T right now. And then I want you to put beside that very first equation that we've used over the last week. I want you to put beside that the letter A. Then I want you to circle the rest of the equations under the kinematics section all together. Okay, one big circle around all 5 of those acceleration equations, and I want you to put a B beside them. Whenever you see a problem now involving constant or average velocity, the kinds of problems that we've been doing for the last week, then I want you to identify that as a group A problem. B. So group A and group B. It doesn't really matter, it's just what I call them. So whenever you see that problem involving constant or average velocity like we've seen for the past week, that's a group A problem, and that's going to be the group A equation. V is equal to delta D over delta T. But whenever we have a problem involving acceleration, speeding up, slowing down, that's a group B problem. And then we're going to use one of the 5 equations that we've just learned. One of the 5 that you see up on the board right now, or one of the 5 that you circled and labeled as B just a few moments ago. Does that make sense? So up until now, we've been able to just look at a problem and almost blindly write down the equation V is equal to delta D over delta T because it was the only one we had. Now what we've got to do is look at the problem that we have, identify first, before we even look at givens, identify first, is it a group A or group B problem? Are we traveling at a constant velocity? Are we speeding up, slowing down? And then once we identify that, pick from the list of valid equations. Good news is, as long as you got the right group of equations, you can't really go wrong. Let's say I identify that it's acceleration. It's an object speeding up, and I pick my group B equation list here. A is equal to delta V over delta T. D is equal to VI plus VF over 2 times T, and so on. I write down my givens. I try to find an equation that fits the givens. If I pick the wrong one, oh well. No big deal. Worst that's going to happen is I'm going to end up with 2 unknowns. Pick again. Maybe I end up solving for something, but it's not what I'm looking for. Pick another one. As long as you're picking from the right group of equations, you might get an answer that's not what you're looking for, but you're never going to get the wrong answer unless you make some mistake, obviously. Yep. Like dynamics, energy, circular motion, and so on? Therefore, dynamics, energy, circular under kinematics? All 5 of those, well, the first one, V equals delta D over delta T, is the one that you've been using for constant or average velocity. But all the other 5 are the ones that we see up on the board here right now, and they're all for problems involving acceleration. So when an object is speeding up or slowing down, all 5 of those are applicable. And in the exact same situation, the only difference between the second equation and the 6th equation is the givens. Okay? They're valid in the exact same situation. One might be more usable given certain things than other, but it's no more valid. And you'll see as we go through some problems here in a few moments what I mean by that. Okay. 1.12 on page 47, we have this hybrid car with an initial velocity of 10 meters per second accelerating at 3 meters per second squared. How long does it take to reach this velocity? I'm going to write some numbers down. You're going to tell me what my givens are. 10 meters per second represents what? Yep. Good. That's my initial velocity. That's how far I'm going or how fast I'm going at the beginning of this problem. What is the 25 meters per second? How long will it take the car to acquire a final velocity of 25 meters per second? It's going to be VF, right? My final velocity. What's this 3.0 meters per second squared? Yep. Yeah, good. It's my acceleration. This is not my change in velocity. It's my rate of change of velocity. It's how quickly my velocity is changing by. I'm looking for time, the amount of time that this takes. So here's what I want you to do right now. Take a look at your data sheet. Knowing this is a group B equation or a group B problem because it involves acceleration, right? We're speeding up, acceleration. Look at the list of group B equations on your data sheet, the 5 that are listed there. See if you can find one that fits these givens. If you can't, that's okay. Pick one. Pick one of the 5. Okay, let's try this one. Is this valid? Vf squared is equal to Vi squared plus 2AD. Is that valid? Sure, it's group B. They're all valid, right? So let's try this. Vf, I've got that. Vi, I've got that. A, I've got that. Oh, solving for D here. I don't know what D is, but I could solve for it by taking Vi squared over by subtracting. And then dividing by 2A, I could get D. That's fine. Is that what I'm looking for? Nope. Is that a wrong answer? Nope. It's like saying, what color is Adam's shirt? And if somebody says, Mr. Dickie's shirt is blue, it doesn't answer the question, but it's not wrong. Okay? That's what we've done here. Okay, we've just solved for displacement when we're looking for time. It doesn't answer the question, but it's not wrong. Okay, if I solve for something that I'm not looking for, that's fine. Just go back and solve for what you are looking for. How about this one? D is equal to VIT plus 1/2 AT squared. How about that one? D, oh wait, I don't know what D is. VI, yeah, T, oh no, I don't know what T is. I got A. Wait, that's 2 unknowns. Can I solve for D and T in that equation? Nope. Have I got a wrong answer? Nope. I just haven't solved for anything, right? Any ideas? It's not all that hard. Yeah. A change in velocity over time. Let's try that, see what happens. By the way, even if Maddie didn't give me the one that I'm looking for here, the most efficient one, it's no worse than what I've already done, right? Solve for something I'm not looking for. Can't solve for anything. Yeah, that's the worst that's going to happen with this one. Let's give it a try, though. Solving for T, get it to the top by multiplying. And then get rid of the A by dividing. Delta V is 25 minus 10 over 3. Well, that works. 25 minus 10 is 15 divided by 3 gives me 5.0 seconds. Look, the more of these you do, the better you're going to get at picking the correct one right off the top. But even if you've been doing it for a while, for years, every once in a while you're going to come across one that you try something like this and it just doesn't get you what you're looking for. So you try something else. By the way, how many digits should this be? I said 2 there, but how many should it be? Riley, was your hand up there? Yeah, it should be 2. This is 3. This is 3. This is 2. And my final answer should go according to the least precise piece of data there. 2 digits. Okay, let's have a look at those 2 questions on page 47, please. For each of them, first identify, is it group A, is it group B? Is it constant velocity, is it acceleration? Then once you do, write down your givens, pick an equation that seems to fit. Don't worry about picking the wrong one, as long as you pick from the right group. Okay, taking a look at number 2, it says an elk moving at a velocity of 20 kilometers per hour accelerates at 1.5 for 9.3 seconds until it reaches max velocity. What is his max velocity? I told you guys not to worry about finding it in kilometers per hour. You get it in meters per second, I'm fine with that. What do we got here? What's this 20 kilometers per hour thing? That is the initial what? Yeah, initial. Let's call it initial velocity, 20 kilometers per hour. It accelerates at 1.5 for 9.3 seconds till it reaches its max velocity. What are we looking for here? Like, yeah, I know it's max velocity, but what variable is that? Yeah, Matty? Yeah, we're looking for VF here. Now, all of those group B equations are valid. You can try any one of them, and 4 of them are not going to get you the answer. That's okay. Just keep trying until you reach this one. We're going to try A is equal to delta V over delta T for this. Even though I don't see VI and VF, you understand that delta V is VF minus VI. So it includes VF and VI already. Let's solve for delta V. The T goes up by multiplying because we've divided by it already. And let's say 1.5 times delta T, 9.3, gives me a change in velocity, delta V, 1.5 times 9.3 is 13.95 meters per second. Okay, we also know that delta V is equal to VF minus VI. So if I'm solving for VF, it's simply going to be, we take the VI over by adding delta V plus VI. Now we do have to be careful here. This 20 kilometers per hour, we would multiply by 1,000 to get meters. We would divide by 3,600 to get seconds. And we end up, I think, with 5.5556. So it becomes 13.95, my change in velocity, plus 5.556, which gives me 19.5, or we'd round that to 2 digits, 20 meters per second. Okay, how many people ended up getting that? Okay, not bad, not bad. It's kind of tricky, eh? You guys okay there? Got it? Yeah, Liam? I had the 5.556 because when I solved for 13.95 right here, this was delta V. Right? That's not what I'm looking for, though. I'm not looking for delta V, I'm looking for VF. But I know that delta V, this, is equal to VF minus VI. So if I rearrange delta V is equal to VF minus VI to solve for VF, the VI goes over by adding. It's subtracted from delta V. I take it over to the other side by adding. So now I've got VF is equal to delta V plus VI, or 13.95 that I just solved for, plus the initial velocity of 20 kilometers per hour converted to meters per second. That make sense? Okay. Let's do another one and then we'll see where we're at for time here, okay? A cattle train, I'm not sure where they get their contexts for this. Like when they're sitting there saying, hey, we should write a question about acceleration. Hey, let's make it a cattle train. Like where that comes from in their mind exactly, but whatever, it works. Cattle train traveling west at 16 is brought to rest in 8 seconds. Find the displacement of the cattle train while it's coming to a stop, extremely uniform acceleration. This is group B because it involves acceleration. We're slowing down this time, not speeding up, but that's okay. You know what I think I want to do for the first time? Find west as positive. Can I do that? Sure, usually I define east as positive, but since everything's moving to the west, let's just deal with positive numbers here. Everything positive is going to be to the west. That means I've got a VI of 16 meters per second, positive, because I've made it positive as west. My time is 8 seconds. Looking for displacement. Is there anything else that I have? If I read between the lines, yep, good. How do you know that? Yeah, it says it's brought to rest. So they tell me that VF is 0, but not in so many words. Right, I got to read between the lines a little bit there. VF is 0 because we're brought to rest. We know it's group B, right? So let's pick from our group B equations, all 5 of them. Which one do you want to try? Let's try the one with the brackets. VI plus VF over 2 times T. Does that work? Well, I got VI and VF. I got T. It looks like it's going to work. VI is 16 plus 0 over 2 times time is 8.0. Gives me 8 times 8 is 64 meters. Yeah, that works. Looking for displacement. That's what I got. Done. Final answer should be 2 digits, of course. This is 3. This is 2. Final answer should be least precise, or 2. Let's have a look at questions on page 48 now, the ones that go along with the previous example.